Good morning. My name is Caroline Worsham, and today I've got a question for you. Have you ever heard of the process of genetic engineering? I know you most likely have heard of several products made through the process, one example being the notorious GMOs, or genetically modified organisms, but genetic engineering is so much more than that, and today we will be looking through many parts of genetic engineering. Before you can understand it, you have to ask yourself, what exactly is genetic engineering? By the definition of the Encyclopedia Britannica, genetic engineering, the artificial manipulation, modification, and recombination of DNA or other nucleic acid molecules in order to modify an organism or population of organisms. An easier way to explain this is that they can change the genetic structure in an organism by either changing, rearranging, or adding strands of DNA, which in turn would change the organism itself, possibly even the entire population of animals if put into effect. Here you can see the three things I just mentioned. So that would be changing, rearranging, and even adding strands of DNA. Did you know that genetic engineering has been used since before 1800 BCE? One of the earliest examples being the mule, the offspring of a male donkey and a female horse. Bred for its strength and resilience. Mostly, it was often used in farm work. As you can see here, horse and donkey made the mule. Another early example is our dogs. Our canine companions trace their roots back to the ancient wolf, where humans sought out to breed the most docile or tame wolves, eventually creating a creature which lacked a lot of the hostility that was in its counterparts. In short, humanity tries to find the good in an animal and breed to carry the good traits to its offspring. Think of it this way. Say we have two wolves. One is an incredibly docile wolf, like seen here, who carries a trait for its calm attitude, and say this trait is recessive, or NN. The other wolf is a really rough and tough fella up there, who's always looking for a fight, and he carries a homozygous dominant gene for aggressive, which is the large N. Looking at it this way, it's likely that none of their pups are going to be really as calm as the mother, as they carry the father's aggressive gene. But say you switched out the aggressive wolf for a much calmer wolf, with a trait for its docility, like this guy. Suddenly you are more likely to receive offspring that carry this calmer genotype. This process of pairing animals that have a similar characteristic in hopes of receiving a specific trait is called selective breeding, or artificial selection. This is a process not only used to develop the dogs and cats of today's society, but one commonly used in areas like the livestock industry and even in horticulture. It's not uncommon for that farmers breed together the most productive organisms in hopes of receiving a larger haul and more amounts of product. No matter if it's the heaviest muscled hogs or the plumpest tomatoes, we've been looking the best way to provide more food faster. This is where GMOs come into play. In the past, humans have always wondered what would happen if we could specifically choose the genetics we want to see in an organism, and with the introduction of gene splicing and genetic modification, now we can. This opens up a whole new world of opportunities for not only the agricultural industry, but for other areas of science. We can now create organisms such as golden rice, which we'll be seeing in a second. The way it works is that you have the genes that you want and the organisms who need them. And so as you can see here, you can take out a portion of that DNA and carry over the gene you desire and put it into the organism. And that's gene splicing. As I said, there's the golden rice that you can see here. It's a genetically modified using marigold genes. So they pulled the marigold gene over and as a way to introduce more beta-carotene into the rice plant, which is a strong source of vitamin A. An issue that rises from GMO is a matter of understanding. You see, genetic modification is a sensitive subject, and while selective breeding is using traits already found in the gene pool of a species, genetic modification introduces completely new genes to a species in itself. This can lead to some problems in GMOs, especially in how we use them. You see, these are pretty much what I like to call the no's of GMOs. Sometimes, these genes can be too overpowered, and if they escape our control or human containment, they can outcompete with native species in an environment and disrupt the balance. Another risk with genetic modification is the altercations it could have on humanity itself. For example, cloning or other methods of genetically modifying possibly the human species itself could become abused in the future, or even just with the animals and plants around us. But despite these faults, I feel like genetic modification is leading us down the right path. With a greater understanding, we can find stricter guidelines and regulations, ensuring the safety of all who use GMOs. Genetic engineering is the foundation of our past, from the wheat fields to corn kernels, and even to that ribeye on your plate. It can be seen in nearly all areas of agriculture. We started off with the finest of our stock, breeding them together to produce the finest offspring possible, and now we've reached a time where genetic engineering is on the rise again through the use of various biotechnology, allowing us to pick the traits we want to see in the next generation. Considering the fact that farmers will need to feed 9 billion people by the year of 2050, as you saw before, we are definitely in the need of new ways to improve our harvests, making them more productive. I hope through this video, you've gained a better understanding of genetic engineering, where it came from, how it's used, and how it could better improve our future.